Hello and welcome to the tutorials on sketching pictures. In a lot of industrial designs, and based on my experience within both the furniture sector, furniture manufacturing sectors, and furniture design, um, it's common that an industrial designer will make a sketch of the product that has to be designed, and then this sketch has to be imported as a picture or a photo in any of the photo formats, or from JPEG, JPEG to any BMG also. Yeah, you know, all the photo formats. SolidWorks can accept them, so you import it into the model. We'll start now. Let's go. Okay, so we go to the front plane. So we are going to start a sketch, and then we will import uh, the picture that we want to design. Right now we are designing a hook. The part is a very simple design, but at the same time too, the part is a combination of different features, but we try to get it as close as possible. We are not going to be very perfect about it. So I mean, you can get better, or yeah, improve from what I've done. So we have to import the picture. Most times we go by insert, but sometimes it can happen that some of our icons are not found there. So you can, SolidWorks has made it possible that we use the search method. So we can say sketch picture. Let's see whether it's going to be here. Sketch picture. Yeah, sketch picture. So the icon opens to the picture. If it doesn't open, you have to search through, and then you open the picture. So there is the picture. When the picture comes in, it snaps in directly to the origo. But in case it doesn't, you can reset the origo. This is the x-axis. This is the y-axis. If you set it to 00, we are working in millimeters, so it's going to definitely send it to origo. Then you have the width, 477 millimeter, and then you have the height, 860 millimeter. So it's a ratio of 1:1. Yeah, but you can change this, if you so wish. But for the purpose of this design, we leave it at this. So you said okay. We'll now make a design. We try to capture this picture as much as possible. We'll do this very fast, so the video wouldn't be too long. So we move first to do the inner ring. This is just going to be approximations all the way. So if you are good in approximating, this is going to be your great. You're going to appreciate this, but otherwise, you just have to try as much as possible to get it approximated to, yeah, the size of the pictures, the edges of the pictures. So let's say, sometimes we can use magnifier G and look at our edges, how good they are. That's pretty not so good. So yeah, we now exit. So we shift it a bit. So okay, G again. We look at our edges. Okay, not too bad, but not as good as what we expect. But we have to just move on. Okay, so we can dimension this to be. So it gives us 124 millimeter in diameter. We can round it up to 125. 24 to 125 here. Okay. Then we can fix it by going through the origo to 70. You can make small adjustments here to have more dimensions without fractions. In real world, it may be different. 681.5. We can take 682 millimeter. So that's back fully defined. We can take, so if we look at this, we see it's a concentric circle. So let's try to get that done. Okay. So, but we see here that if we open the, yeah, that's not good. So we can try to float the dimension once more. I'll try to push this in, and so to put it to this. It's already concentric. So I'll try to see whether we can. Yeah, let's see. Yeah, okay. So all right, we are just doing this approximation, so let's not spend too much time on it. Yeah, so okay. So all right, let's dimension this to this circle to 277. Okay, let's dimension this to 679. And I'll take 680. Say hash it is much it is, and then this is 270. Really define both of them. Okay, so we now do the spline lines. We are going to break it in segments. So let's see. Let's break it in segments. And when we get somewhere here, let's say that's segment 1. We'll try to get it. Let's see if we can get a tangent. Okay, because it's a circle, it won't tangent. Okay. Tangent. So there, that shifted too much. Okay, we're just trying to see how much we can fit in these lines to the edges. Okay. We see that's maybe somewhat better. Let's see whether we can do something there. If we at this point it begins to curve, yeah. So if we drag it a little bit down to see whether it's better. No, okay. I think it's pretty okay, yeah. The former position seems to be better. Okay. So we take the next one. We use splines. Oh, true. Okay. Let's see whether I can get this. Get this. Get this. Get this around here. Okay. Let's add a control point here. Spline control. Let's insert a spline point somewhere here and see whether we can get it to follow better. Okay, that's pretty good. That's the nice things with spline lines. We can shape it by adding extra control handles. Okay, so all right. Okay, but that's not okay. Well, I mean, if you've worked with spine lines, so that shouldn't be a problem. So, otherwise, we'll have more lectures where I talk about spline lines. Okay, so that's yeah, pretty okay. We take, I will just survey it for a moment, and then I think that'll be okay. Then we can draw one more line to somewhere here, one more spline to from here, and then we'll stay here. Give it 2 control points. So let's see whether we can create a tangent. Yeah, so they can tangent very well. Tangent is a flow smooth, so it can flow smoothly. So yeah, we can add more splines here. So add another spline here. So we can just say this is okay. So we'll see how much we can follow this curve. So, but I mean, for those who have worked with spline, you know how to do this. So yeah, I'm just doing my best to get them follow the curves. Alright, it's just illustrative purposes. And then I would like to use straight lines here. If I can use a straight line here. So I try to avoid automatic constraints, additions. They can create a lot of problems in our design. So okay, this sounds like a straight line. Yeah, no, that doesn't really fit. If we can start here and then somewhere here. So and then because of that one we will use this one, so the two of them can have the 2 points there can be parallel to each other. This point can be parallel to this point. So let's say, so let's see whether we can join this one, join it. Then that means we adjust our spline a little bit, and let's test whether we can add a tangent. Okay, so that okay. If it doesn't really agree, we can add insert 8-point control here, so it will come out better. Okay. Straight line fused into splines are always not easy, because straight lines by mathematical definitions aren't so easy to fuse with a spline, which is more flexible. Yeah, but we're not gonna spend so much time here, so we'll move on. Okay. So okay, I have to hurry and get out of here. So let's see how this works. So let's add a spline point here. That's spline point. So we can be able to drag it this, yeah, and then so so shift this line. So we just have one place left, which is here. If we bring this one down here a little bit, okay, and then let's see using can use 3 point, let's say tangent arc. Let's test it on the arc. What reactions we're gonna get here? If we so so okay. Okay, well, we're not going to spend so much time on this. You can check up how to work with spline lines. So, okay, let's put 2 construction lines here that are let's just draw it. Yeah, and then put another one vertical. Then say that this coincides with this. Oh, just consider it. So, and say this one coincides with this. Oops. I'll shorten it a little bit. Okay, that's good. And then put a construction line that is at the midpoint here and goes right through. But we'll need all this in these design processes. Okay, all right, thank you so much. We'll continue with section 2 of this where we'll put in our planes and all that, but yeah, okay, so thank you.